Hey everybody, this is Chapter 9, Section 1. Title is Quadratic Graphs and Their Properties. Starts on page 534. First, we have to look back at some old material that we've done before. We talked about graphs back in Chapter 5. When we were in Chapter 5, we were doing linear equations and linear graphs. So remember, in a linear equation, the exponent on the x is always a 1. So an example of that would be like y equals 3x plus 2. You see the x, there's no exponent written up there, which means that the exponent is a 1. That is a linear equation. The graph of a linear equation is always a straight line. If you look up the graph at the top right-hand corner, you see that solid line, that straight solid line. That is an example of a linear graph. A linear graph is always straight. A linear equation always has an exponent of 1 on the x. That's stuff that we've already done. Now we have to move into some new stuff, some quadratic stuff. We first used the word quadratic in the last chapter when we were talking about the fact that quadratic means that the exponent on the x has to be a 2. In a quadratic equation, the exponent for the x is always a 2. That's what quadratic means. An example of that, y equals 5x squared plus 7x minus 4. You see the exponent on the letter x is a 2. That makes this a quadratic equation. It doesn't matter that the exponent on the plane x is a 1. What you're looking at there is for the biggest exponent, which is a 2. We said that a linear graph is a straight line. A quadratic graph is a curved line called a parabola. If you look at the graph in the top right-hand corner, the dotted line is an example of a parabola. You see it's kind of U-shaped. That is a parabola. Graphs of quadratic equations are always parabolas. Sometimes they open up and look like a U, like the one that's up there. Sometimes they're upside down and open to the bottom, like that red one that I drew looks more like the letter N instead of the letter U. We'll talk about what the difference is between those in a minute. Most quadratic functions look similar. They follow the same pattern. Most of them look like y equals ax squared plus bx plus c. And a, b, and c are just plain numbers. Y always stays y. You always have the x squared. You always have an x. The number parts can change. The number that's in the a spot has a special name. It is called the leading coefficient. Coefficient just means number in front of a variable, and they call it the leading one because it's at the front edge of the problem. So A is the leading coefficient. I'll talk about the leading coefficient a lot more in the next couple of screens. We've got a graph up there. No problems right now at the beginning of this lesson. I mentioned in class that there's lots of vocabulary, so we have to get this vocabulary out of the way first. Parabolas have what's called symmetry. Symmetry comes from the word same. And so what this means is that you can divide the graph straight down the middle so that the right side and the left side are the same. They match exactly. Symmetry means that the right half and the left half match each other exactly. Next definition, the axis of symmetry. The straight line that divides the parabola into its two halves. In the graph shown over there on the right, the axis of symmetry is the dotted line. So, half of the graph, the right half of the graph, if I make it this red line, and the left half of the graph, if I make it this green line, match exactly. And the spot that is, or the line that is directly in the middle that splits it in half is this dotted line called the axis of symmetry. So axis of symmetry in this case is that dotted line. Axis of symmetry splits it straight down the middle. Another definition. The highest or lowest point on a parabola is called the vertex. It can be either the highest or the lowest. In this case, the vertex is this black dot. In this problem, it is the lowest part of my parabola. There's nothing on that graph that's any lower. Let me get rid of some of those colors so they're a little easier to see. That black dot is the lowest spot on that parabola. That is its vertex. The vertex is always on the axis of symmetry. So it's not going to be off to the side anywhere, but the vertex, that dot, is always going to be laying on top of that dotted line. It says in the graph shown, the vertex is this dot. So the graph itself is the solid line, the axis of symmetry is the dotted line, and the vertex is that big black dot. If you have any questions about those definitions, make sure you write them in that box 8, where we have time for questions tomorrow in class. Couple more definitions. If the leading coefficient, remember that letter A, if the leading coefficient is positive, the parabola opens upward, and the vertex is called a minimum. So the parabola opens upward. It acts like a bucket, and it would catch rain if the rain was falling. The vertex is called a minimum because it's the lowest point on the graph. So down here, that would be the vertex, and in this case, the vertex would have a special name, and it would be the minimum. Okay, there's two different types of vertex. There's the minimum when it's the lowest point. The vertex is called the maximum when it's the highest point, and that's the next one we'll do. So this is the minimum because it's the lowest spot that there is on that graph. Over here on the right, if the leading coefficient A is negative, the parabola would open downward. It would have an N shape. In this case, the vertex is called a maximum. It would be up here because it's the highest point on the graph. That one looks more like an umbrella. The rain would slide off the sides of it instead of gathering in the bottom. So in just a second, we're going to look at some problems, and we're going to look at these leading coefficients. And we're trying to figure out if the graph that we have would open upward or would open downward. And you tell that based on what number is where the A goes. First example problem, it says, what are the coordinates? Coordinates means ordered pair, an X and a Y. So what are the coordinates of the vertex of each graph? And then it also wants to know, is that vertex a maximum or a minimum? Example 1A is this graph right here. The vertex is the highest spot in this graph because it opens downward, so we're looking at the top of the mountain. There's where the vertex would be. I have to find the ordered pair for that. So, X goes side to side, but from the origin I don't go side to side at all. So I travel 0 side to side. And then I go up 1, 2, 3, 4, 5, 6, 7 places. So the vertex would be at the coordinates, or the ordered pair, 0, 7. Since that vertex is at the top of the mountain, that would be a maximum, because it's the highest spot on that graph. Example 1B, vertex in this case is down here. We have to figure out what ordered pair that dot is. So from the origin, we have to go 1, 2, 3 places to the left. which tells us -3. And we have to go 1, 2, 3, 4, 5, 6, 7, 8 boxes down, which tells us -8. So that red dot is at the ordered pair 3, -8, or -3, -8. That's the vertex. Since this graph opens upward and our dot is at the bottom of the valley, that makes it a minimum. Remember, the directions for that ask you two different things, so make sure you give two different answers. If you have a question on that, make a mark on it, or make a note in your questions box, and we can come back to it in class. Next topic, new stuff. You can use a table of values and a symmetry shortcut to graph parabolas. In the past, we used tables of values, XY tables. We picked a whole bunch of X's, plugged them in, figure out what the Y's were that went with them, and graph those ordered pairs. The good thing about a parabola is you can get away with only graphing half of it with a table of values. So the steps that we need to follow: first, find the vertex and use a table of values to graph only several points on one side of the vertex. Then, in the next step, count the number of spaces from each point to the axis of symmetry. I'll go through these steps again when I actually do the problem. It'll be easier to follow. Count the same number of places to the opposite side of the axis of symmetry and place a dot. In these problems in this section, the axis of symmetry will be the y-axis and the vertex will always be at the origin for these problems right here. Okay? In other sections, we'll change that later on. First example, 2a. Graph y equals -3x squared. So, need to make an xy table. I'm going to choose some x values. For this one, remember, you want to use values that are small so that you don't have to work with numbers that are very big. So I'm going to use 0, 1, and 2. Now, one of the things you should know about quadratic equations is that when you start plugging in numbers, your answers get really big really fast because you're squaring things. So you want to pick as tiny a numbers as possible. If I plug 0 in for x, 0 squared is 0. 0 times -3 is still 0. So there's my first ordered pair. So I put a dot at 0, 0. Next, I plug in the 1. 1 squared is 1. 1 times -3 is -3. So I have the ordered pair 1, -3. So I go to where x is 1, go down to where y is -3, and I put a dot for that ordered pair. I do it one more time with the number 2. 2 squared is 4. 4 times -3 is -12. Wow, that was a really big jump. That's what happens when you have quadratics. Your values make really big jumps. If I did x equals 3, you don't have to do this one, but if I did x equals 3, 3 squared is 9. 9 times -3 is -27, and we are way off the graph now. Okay? I still need a dot for 2, -12. This graph actually has 12 places going up and down, so it should be right there. So what I've done is I've graphed the right half of this parabola. I don't have to use ordered or table of values in order to graph the left half. I can use a shortcut. The axis of symmetry in this problem is the x-axis. I'm going to make that blue. Goes right down the middle. Now, my first red dot was right there. That's my vertex. My next red dot is one place to the right of the axis of symmetry. So I also need to place another dot one place to the left of the axis of symmetry so that they match. One on one side of the line, one on the other side of the line. This dot here at the bottom is two places to the right, so I need to make another dot two places to the left. So instead of having to find 5 ordered pairs to graph this, I only had to find 3. The 2 dots that are on the left of that blue line, I could just use because the right half and the left half always match. It's like looking in a mirror. The stuff on one side matches the stuff on the other side. Okay. So I draw my line through the right half, draw my line through the left half. There's my parabola. Graph one side of it using a table of values. Graph the other side of it because we know that the axis of symmetry always acts like a mirror. Everything that's on the right matches the stuff that's on the left. Example 2b, graph y equals 1/4 x squared. Table of values. Now I'm going to choose my numbers carefully here because I don't like working with fractions. Okay? If you remember, when we graphed before, if you had a fraction, your x's should always have been multiples of the denominator. Denominator is 4, so I would normally use 0 and then multiples of 4, which are 4 and 8. There's a problem with this, though. Remember, when you go up, when you plug in bigger numbers, you get much bigger answers. We'll see what happens there. If I plug in a 0, 0 squared is 0, 1/4 of 0 is still 0. There's my first ordered pair. It's at the origin. If I plug in a 4, 4 squared is 16. 1/4 of 16, or 16 divided by 4, is 4. So my next ordered pair is the ordered pair 4, 4. 1, 2, 3, 4 to the right. 1, 2, 3, 4 up. Now, if I plug in 8, 8 squared is 64. 1/4 of 64 is 18. My graph only goes up to 12. So the graph for the point 818 would be like way up there. That doesn't help me. Not really. Because I need something else that's on the graph. So what I'm going to do is, even though it's not a multiple of 4, I'm going to see what happens if I plug in the number 2. 2 squared would give me 4. 1/4 of 4 is 1. That would definitely be on my graph. So now I have a third thing that's on my graph. The ordered pair 2, 1, so I go right 2, up 1. Now I have 3 dots on my graph. That's what I need in order to make a parabola. Again, the axis of symmetry, in this case, is the y-axis. I'll draw that in there. Here's my vertex. It stays where it is. My next dot is 2 places to the right of the axis of symmetry. So I need another dot that's 2 places to the left of the axis of symmetry. The next dot on the right is 1, 2, 3, 4 boxes to the right. So I need a dot 1, 2, 3, 4 boxes to the left. That dot way up on top didn't really mean anything, but I can put a match to it pretty close to. There. Now I have something to aim for when I draw my line. Draw my right half. Draw my left half. There's my parabola. If you have any questions about that process, make a note on box number 8. Next topic. Let me back up a second. On this graph, you notice a few things. If you look at example 2a, this letter A, the number in the A spot, is negative. Negative means that your graph is N-shaped. It opens on the bottom. Over here in example 2b, the number that's in the A place is positive. Positive means that your graph is U-shaped. It opens up. But the number A also tells us something else. In example 2a, we've got a 3, and we got a very narrow graph down here at the bottom. In example 2b, the number was 1/4, and we got a very wide graph. That's going to tell us something. As we just saw in example 2, the leading coefficient A affects the width of the parabola, and it affects the direction that it opens. The farther away from 0 the leading coefficient is, the narrower the graph. The farther away from 0, so like a big positive number or a big negative number, that gives me a narrow graph. Closer to 0 means a wide graph, so that would be like a positive fraction or a negative fraction. Example 3 says, which of the following functions is the narrowest and which is the widest? So remember, narrow means farther away from 0. So a big positive or a big negative. Close to 0, like a fraction, means that the graph is wider. So here's the 3 you have to choose from. The narrower one is the number that's farthest away from 0, the biggest positive or the biggest negative. The 5 is the number out of all 3 of those that's farthest away from 0. So it gives you a narrow graph. The other 2 choices, I've got a half and I've got a 1/4. Which one of those is closer to 0? 1/4 is a smaller fraction, so it's closer to 0. So this would be your widest graph. The one that's 1/2 would be the one that was in the middle. Not narrow, not wide, but somewhere in the middle. Okay. Remember, the negative sign tells you if it's going to open up or open down. The size of that number, how far away it is from 0, tells you it's going to be wide or narrow. Last topic. We've talked about the leading coefficient A. Now we're going to talk about C, that number that comes at the very end of the equation. The C is going to take your graph and it's going to slide it up or it's going to slide it down. If C is positive, the graph slides up. If C is negative, the graph slides down. You don't have to graph this one in example 4. I'm going to graph it when we're done just so I can show something to you. But you don't have to graph it in order to figure it out. How are the graphs of y equals x squared and y equals x squared minus 3 related? Well, if you have a minus 3 at the end, that's my C number, the number at the end. If your C number is negative, the graph is going to slide downwards. So, what this means, all I need to write for my answer is that y equals x squared minus 3 is slid down 3 places. If I graph both of those real quick just to show you what the difference would be. Put a graph up there. Move it out of the way. The graph of y equals x squared would be something like that. The graph of y equals x squared minus 3 would be the same width. It would still be opening up. The only difference is that the vertex gets slid down 3 places. So it would be like that blue line. All I did is I took the graph, same graph, and I just slid it downwards 3 places. That's what that number at the end tells you. If it was a positive 3, I'd slide it up 3 places, and it would be this green line. So the C at the end slides that vertex straight up or straight down. Don't forget, if you have any questions or anything, place them here. See you in class.